And record.
Hey
guys. Oh, sorry.
It's okay.
We're going to teach about length, area, and volume, Module 3, Chapter 10. My name is Danielle Gillham.
I'm Mackenna, sibley.
And I'm Regina, Lusby, and we're kind of missing one of our classmates tonight. She lost her mom recently, so she's not able to record with us this time. So if you guys will keep her in your prayers, we'd appreciate that.
All right. Regina, in the doubling system of capacity measure, in order to use the doubling system of capacity measure, what do we need to know?
Well, the first thing we need to know is we kind of need to know what units we're actually working with. And some of the units that we looked at this week are not things that I think of that we would normally use. So we basically just need to know what those are and what they're equivalent to in order to be able to figure out what our measurements would be. So if it was 1 jigger, it tells us that equals 2 mouthfuls. If it was 1 pint, that equals 2 cups. 1 jack is the same as 2 jiggers. 1 gill is 2 jacks. 1 quart is 2 pints. 1 bottle equals 2 quarts. 1 cup equals 2 gills. 1 gallon would be 2 bottles, and 1 pail equals 2 gallons. And so you could just use that chart and then look at the information that you are asking for to help you figure those out.
Okay.
Thank you.
Super cute setup.
Thank you. All right, Mackenna, how could you find out how many mouthfuls go into a gill, a cup, and a pint?
Kind of what you said just a second ago. So we had the list of how many goes in each, and then in this you find out that 2 mouthfuls equals 1 jigger, and then 2 jiggers equal 1 jack, and 2 jack equals 1 gill. So you kind of just double the mouthfuls since it's 2 to 1, and then you get the total of 8 mouthfuls equal a cup. Or I'm sorry, a gill. And then you double that and you get 16 equal a cup, and then 32 equal a pint.
Okay, that totally makes sense.
Danielle, in a gallon of water, 1 pint was removed, and what is remaining about in jacks?
So if we have our gallon of water, I've already put up a chart that shows the amount of mouthfuls in each measurement. So if you have your, oh, there it goes. We have 256 mouthfuls in gallons. And then if you subtract the 32 mouthfuls that's in a pint, you're going to get 224 mouthfuls. So then you'll do the 224 divided by 4 mouthfuls per 1 jack, since one jack equals 4 mouthfuls, and you're going to get 56 jacks are left after you subtract your pint from your gallon. That's it.
Okay, that makes sense. And I don't know how you write so neat and fast with that, because I'm not very good at that.
Me either.
So Regina, area and perimeter of triangles.
Okay.
What do you need to find the area and perimeter of a triangle?
Okay. Well, for each of those, we're going to have a formula, and I think I have one more animation there. Pop up. See, there it goes. All right, so what you really need to know is you just need to know the formula for each. And so for your area formula, your area is half the base times the height. And then the perimeter formula is your perimeter is your A plus B plus C. So all you do is take those 2 formulas and then plug the numbers in that are given to you. And then as you can kind of see below, that helps you to work those problems out. So they're pretty simple.
Okay. Thank you.
All right, so Mackenna, what is area and perimeter?
So area and perimeter. Area is the space occupied within the shape of anything, and perimeter is like around the shape And then, like you said, you just use those two formulas to figure out what it is.
Okay. That's a good explanation.
Danielle, how could we find the hypotenuse, or side C of the measurement, if the measurement wasn't given?
Okay, so say if we weren't given this right here, and we needed to find it. So you're going to use this little equation right here, a squared plus b squared, and that's going to equal your side C. This is side A, this is side B, and this is side C that we're trying to find. And so you're going to have 37 squared plus 88.8 squared, and that's going to equal 96, sorry guys, 96.2 inches. And that's just how you'll find that. That's it.
Okay.
That's pretty simple.
Yeah.
So Regina, calculating the area of circles and squares.
Mm-hmm.
What are the steps to find which of the areas are bigger? The area between the circles or the area inside the smaller circle?
Okay. All right. Let me get one more click there.
Okay.
There it goes. Okay. So basically all we really need to know is we need to find our area of our smaller circle, and then we need to find the area of the larger circle. Same thing, we have a formula to do those. And then after we do that, we're just going to take the larger square and we're going to subtract what we came up with for the smaller square from that. And then that would give us the amount that we were looking for. So again, it's just working with those formulas and then just subtracting one from the other.
Okay.
Okay.
Really like those formulas.
Yes.
Okay, Mackenna, how would you find the area of the center circle?
Kind of how you said last time. So we have the units of the square, 10. So that would make the radius, which is the R of the circle, 5. And you would square that to get 25. And then you would just multiply that by pi and you get the answer.
Okay, that's pretty easy.
Yes.
Thank you.
Uh-huh.
Or Danielle, what is the difference in an area between the square and the smallest circle?
Okay. So if we were to find this difference right here, if that was all shaded in, we would find the area of the square, which will be 10 to the second power. You're going to multiply two sides, and that's going to be 100. And then the smaller circle, like you said, is pi times radius square, which in our case, the radius is half of the square, which is 5. And that's going to equal 25 squared units, or units squared, which is also equivalent to 78.54. And so 100 minus 78.54 equals 21.46 units squared. So that's how much all that shaded information or shaded amount was. But if we wanted to sum it down to how much is each area, we would then divide it by 4, which equals about 500 or 5.37 units squared.
Okay.
Good job.
Thank you. And the ratios of the volumes of the cone to the sphere to the cylinder. Regina, what do we need to find the ratio of the volumes of each of the figures below?
Okay, well, in order to find those, we actually are going to have to know, let's see if we can get one more click there. I think they'll pop up. There we go. So what you're going to have to know is you're going to have to know the volume of each one of those in order to figure out what the ratio is. So again, we're going to use one of our formulas, and we're going to figure the volume of the cone, the volume of the sphere, and the volume of the cylinder. And then if I can get one more click, then you can see how that one worked out with the 1 to 2 to 3 ratio. But before we could do that, like I say, you'd have to figure each one of those individually, and then we could actually look at it and we would know what the ratio was.
Okay,
Thank you.
You're welcome. So Mackenna, it says, how you find the volume of the cylinder, sphere, and cone? How do you do that?
kind of like you said, one, we don't have the measurements to exactly solve it, but if you did have the measurements, you would just insert the radius as the R, and then the height is H, and then you would just solve those, like in the equation, you would plug it in, and it would give you how much the volume is.
Okay.
Right. Thank you. Can y'all see that?
Yes.
Now I can. All right. So Danielle, out of the 3 shapes, which shape do you think would be best at storing a larger volume just by looking at the image and the equations?
Okay. So y'all have explained how to use the formulas and to find the ratio, and the ratio really helps. If we were just like looking at this at a glance, we weren't trying to find the ratios. We were just trying to figure out, you know, which one's bigger. You can obviously look at the picture and tell that the cone and the sphere fit inside the cylinder, so those are going to be smaller. But another way at looking at these is they all have the similarity of pi r cubed in their equation, but the circular cone, which I think is actually supposed to be 1/3, has 1/3, and this is 1 1/3 in front of the equation. This one has a full 2, so that's how you could tell that this one's going to be bigger and store a larger amount of volume.
Okay.
Yeah. Okay. Good job.
Thank you. In surface areas of figures, Regina, what are the basic steps to finding the surface area of a figure?
Okay, so in order to find that, this is a right trapezoidal prism. We're going to go back again, and it's all about those formulas. And so the first thing we're going to have to do is we're going to have to find the base, and we have a formula for that, the 1/2, the A plus B, and then plus the height, and then we'll get to work that out, plug our figures in and get the answer. And then the perimeter, the same thing. We know we're just going to add all the sides together. On that one, it's the 26 to 12, 17, and 15. And then once we get those figures, we go down to our surface area formula, and we're going to just plug those 2 figures in there. So we have the 2 base plus the perimeter and the height. We'll plug those in, and then that would actually give us the amount for our surface area.
Okay. Thank you.
Okay, so Mackenna, how do you find the surface area?
Kind of like what you said, it's all about the formula. So for this picture, you can see that the height is a 7, and then the base height is 17. Side 2 is 15, and then side 3 is 8. And then you kind of just plug those into where they belong in the formula. And as you can tell, as I worked it out, you kind of get the answer.
Okay.
Thank you.
Yeah, got to have that formula.
Yes. What process can we use to find out the name of these shapes, Miss Danielle?
So, just to find the name of these shapes, if you were to look up the shape, you don't really know what it is, and you counted the faces, the vertices, and the edges, a 3D shape with 6 faces, 8 vertices, and 12 edges is going to give you a right trapezoidal prism. And then over here on this one, if you were to look up a 3D shape with 5 faces, 6 vertices, and 9 edges, you are going to get a right triangular prism. And that's pretty much it.
So it's just as long as it matches all of those numbers, then that's how you figure out what the name is?
Yes.
That's pretty interesting. Okay.
Okay.
In surface area and volumes of solids, Regina, what are the formulas you would use for the to find the surface area and the volume of a solid?
Okay. So can you give me a couple of clicks on that one, please? Yeah. All right. So for your surface area, we have the 2 pi, the radius and the height, plus the pi radius squared. And so you would use that formula. Again, you're going to just plug those numbers in and work that formula out. And then for our volume, we have the 4/3 pi r cubed plus the pi r squared height. And same thing, plug your numbers in there, and that is how you find your volume.
Okay. Thank you.
Uh-huh. So McKenna, how do you find the surface area of this figure?
So, one, you can't find this like just a shape at once. You kind of have to tear it apart, and you can see that the top is a cone, and then the bottom is a cylinder. And so you plug that for R, and then you just take H, which is for the cone is 6, and the cylinder is 10, and you plug that for H, and you solve for each of the shape, and then you just add them together to get the total figure, if that makes sense.
Yes, so you figured a different amount for each one, and then you just added them together.
Yes.
Is that okay? Yes, that makes sense.
Okay, thank you.
Danielle, how do you find the volume of this solid?
So you found the surface area, so I decided to find the volume. And you're going to use this equation right here, pi r squared times height 1 plus 1/3 times base times height 2. And so in order to find height 2, it's this right here that we don't know. And so by using the formula of that, of the slant of the cone squared minus r squared. So the slant of the cone is 6 minus the radius, which is 2, and that's going to equal 5.66 meters. And then in order to find the volume, you're going to plug in this equation right here, and that's going to be pi times 2 squared times 10, and then plus 1/3 times the base times height squared. So after all that, you're going to get 149 meters square. And that's it.
So that one had a few more steps to it. It's a little more complicated, I think.
Do what?
I said that had a few more steps to it. It was a little more complicated.
Okay.
Yeah.
And that's it. So thank y'all for watching our video and learning with us.